In this video, we are going to talk about how to graph cosecant and secant, which are the reciprocal functions of sine and cosine. So the first thing you should do is fill in this table of values for sine and cosecant, and for cosine and secant based on your unit circle. So go ahead and pause the video now and fill in those points. All right, first let's focus on sine and cosecant. So I'm going to graph the sine function like we learned last unit. So I'm going to label my x-axis with 0, zoom in a little bit here, pi over 2, pi, 3 pi over 2, 2 pi, and a maximum of 1 and a minimum of -1. I'm also going to label to graph 2 periods to kind of show the pattern. So sine starts at 0, 0, then goes to the maximum, goes to the middle, goes to the minimum, goes to the middle. If I graph the reflection, it's going to go the other way like this. So by graphing my sine function, it would end up looking like this. Now, let's look at our table of values. Everywhere where my sine is 0, my cosecant is undefined. So what does that mean graphically? Graphically, that means everywhere where your sine is on your sinusoidal axes, my cosecant is going to have an asymptote. And since we're talking about the reciprocal function, everywhere where I have a maximum is going to become a minimum, and then we're going to have these little mini parabolas in between my asymptotes. And so my cosecant function is going to look something like this, what I graphed in red. So the period is not going to change. My vertical asymptotes, we have to figure out how to write an equation for that. So my vertical asymptotes look like they're repeating every pi. So I'm going to write that as pi times k, because pi times 0 would give me this asymptote at 0, pi times 1 would give me pi times -1 would give me negative pi. So that's going to help me get those asymptotes. Symmetry is with the origin, because we know that our sine symmetry is with the origin, so is our cosecant. My domain is going to be x such that x cannot equal the asymptotes. So my asymptote equation is going to be part of my domain. Now my range is going to be the opposite of sine. So sine was between -1 and 1. Now it's going -infinity to -1 included, union 1 included to infinity. All right, let's do the same thing for cosine. So I'm going to label my cosine . Now cosine starts at the maximum, goes to the middle, goes to the minimum, goes to the middle, goes to the maximum, and it'll do the same on the other side. So my cosine function is going to look something like this. So again, if we look at my table, everywhere where cosine is 0, my secant is undefined. So everywhere where my cosine hits the x-axis or the sinusoidal axes, I'm going to have asymptotes. And then similar to cosecant, secant is going to have these mini parabolas at those maximum and minimum points that stay between the asymptotes. So similarly, the period's still going to be 2 pi because nothing changed about the length of the cycle. My vertical asymptotes, they're going to be a little bit different. If you notice, my vertical asymptotes are pi distance apart. So pi k is going to be part of it, but it doesn't start at pi. It starts at this like pi over 2. So we're going to have pi over 2 plus pi k. So basically starting at pi over 2, if I add or subtract pi, it's going to give me the asymptotes. Now, I could have also started anywhere. I could have set it negative pi over 2. I could have set 3 pi over 2. It doesn't matter. But in general, I'm starting at a half marker and then adding a whole marker. All right, the symmetry of cosine is with the y-axis. So the symmetry of secant is also with the y-axis. Now my domain, again, follows my vertical asymptote. So x, except that x cannot equal every time there's pi over 2 plus pi k. and then my range is going to be the same as above. So negative infinity to negative 1 included, 1 to infinity. All right, let's skip to page 14 now, and we are going to graph this negative secant function. So I want to keep in mind that this is 1 over cosine, so I'm going to use my cosine pattern. My period is still 2 pi because my b value here is 1. I'm going to have an upshift of 1, but my amplitude is still 1, so up to 2, down to 0. But there is going to be a reflection. But there's no phase shift, so I'm still just going to label my x-axis like normal. And then I'm going to plot my key points. So cosine starts at the maximum, goes to the middle, goes to the minimum, goes to the middle, goes to the maximum. My middle points are where my asymptotes are going to be. My minimums are going to go down, and my maximums are going to go up. So for this graph, my domain is going to be x such that x cannot equal, well, it's similar to what we did before because we didn't change our axes at all. If I start at pi over 2, if I add pi k, that'll show me where all the asymptotes are. My range is going to be negative infinity to 0, union 2 to infinity, because we have that break from 0 to 2. All right, let's do the same thing with this graph. So I have an amplitude of 2. I don't have any up or down shift. So if I'm labeling my x and y or my y-axis, it'll look like this. My b value is a half. So remember when we're finding the period, we do 2 pi divided by b. So 2 pi divided by a half is the same as 2 pi times 2 over 1. So my period is going to be 4 pi. So I'm starting at 0, and I'm ending at 4 pi. So halfway would be 2 pi. Halfway here would be pi, and halfway here would be 3 pi. And we can save the domain and range for when after we graph. So remember, cosecant is 1 over sine. So I'm going to use a sine pattern when I graph. So sine starts in the middle. It goes to the maximum, except for, oh wait, this is reflected. So it's going to start in the middle, go to the minimum, go to the middle, go to the maximum, go to the middle. So now everywhere where it's in the middle, those are where my asymptotes are going to be. My minimum is going to go down. My maximums are going to go up. So our graph will look something like this. So my domain is going to be all x such that x cannot equal pi k again, because we didn't change. Oh no, it's going to be they're every 2 pi, so it's 2 pi k. And then my range, negative infinity to negative 2, stop, union, start again at 2 to infinity. All right, let's go the other way now. Let's write a possible equation for this graph. So the first thing I'm going to do is label these critical points that I know here, so I can kind of see them. And I can see this one's at negative 1, and this one's at negative 3. Be careful about the scale. So I can see that if this minimum's at negative 1 and this maximum's at negative 3, that my middle, or my sinusoidal axes, would have been at negative 2. So I would have had a point here, and a point here, and a point here. And so if I was graphing a sine curve, it would have looked like this. So my first instinct is to write this as a cosecant curve, because I'm seeing a sine curve. So I'm seeing a cosecant curve with no phase shift, but with a vertical shift of down 2. And I can see that I'm starting at 0 and ending at 2 pi, so I can see that my period is 2 pi. And so that means my b value would have to be 1, because we know that 2 pi divided by b is how I get my period. So I was going to write this equation, be y equals, well, okay, what's the amplitude? Distance here is 1, distance here is 1. So 1, or just cosecant of x, down to minus 2. Now let's say you had to write an equation for secant and cosecant. So if I was writing it for secant, I want to look for a cosine type structure. So if I started it here at the maximum, let's say, and my cosine went from here to here, that would be a secant graph shifted right pi over 2 down to. Let's say instead you wanted to start your secant graph here, and it was going to be a reflected cosine, or reflected secant. It'd be negative secant x plus pi over 2 minus 2. So just like when we're writing equations of sine and cosine, there's many different ways to write this equation of secant and cosecant.